Hello, my name is Dr. Granger, and I wanted to walk you through an important concept in mathematics, the order of operations. This comes up often with this mnemonic, this memory device, Pemdas, parentheses, exponents, multiply and divide, add and subtract. But what I want to share is that we could have also called that PED-MSA, because the divide and multiply can swap order. The subtract and add can swap order. So instead of please excuse my dear Aunt Sally, we might have please excuse dear my Sally Aunt. The reason for this, it's not subjective. It's not, oh, how do I feel today? No, it's completely based on what comes first when we read the problem left to right. So for the multiply and divide, if the divide comes first in the problem, then we do the division first. For the add and subtract, if the subtraction comes first, then we do the subtracting before adding. Let me show you an example that comes up so often. The 6 divided by 2 times a quantity of 1 plus 2. And let me tell you that this is firmly always 9. It's not sometimes 9. I assure you it is always 9. It is never 1. But if you're looking at it and you're one of those students who thought, oh, I'm sure it's 1, you're not alone. It is a common error. But here's the little mistake you're making. When we see this multiply and we jump with PEMDAS, we jump to the multiply before we do the dividing, we're doing this out of order. This has to be done division first. I know what some of you are going to say, but wait, I learned math back in the 50s. And that's not how we did it. Well, let me show you what I've done. I found this standard arithmetic book with answers, and it's copyright back to 1892. My printing was in 1911, but you can see that this first copyright, this book was written in 1892. And in this book, they assert that 6 divided by 2 times a quantity of 1 plus 2 is in fact equal to 9. So if you're going to tell me that you learned this differently back in the day, I want to know if you've maybe learned math before 1892. I'll look for another book that's even older, but I feel quite certain that even before 1892, the mathematics and arithmetic books that were printed, if they were doing this correctly, they did this the same way. So here's a picture of page 83 from that book. And you'll see further, simplify each term if necessary by performing the multiplication or division indicated. So notice that we're going to do the multiplying and dividing based on whichever one comes first. Yeah, look at this in case you're interested in this. They called some of these signs not parentheses or grouping symbols, but signs of aggregation. So that is a little bit different back in 1892. But the mathematics, so the English, the language, yes, that's changed a little bit. But the mathematics of how we do this, where we can put the divide before the multiply or the subtract before the add, whichever comes first, this has not shifted. It hasn't changed. So let me show you a little bit why. Or let me go back to this page to do this. I think almost everyone seems comfortable with the adding the 1 and the 2 first, because we're so accustomed to doing what's inside parentheses first. So yes, I think almost everyone is probably comfortable with this. And I'm going to change it to a multiplication cross. So 6 divided by 2 times 3. And what we're going to do is multiply or divide, which the order is whichever one comes first, and it's the divide that came first. 6 divided by 2 is 3, and now we can multiply. 3 times 3 is 9. Let me show you one other way that you might see this. Not another way to do the problem, because the answer is always 9. But let me show you another way that you might envision this problem. Did you know that this division symbol means fraction? So if I were to write 6 divided by 2, that's the same as 6 divided by 2, 6 over 2, a fraction, 3. So if I rewrite this as 6 over 2, notice that that's not 6 over 2 times 3, right? That's not 6 over 2 times 3. If I were to do 6 divided by 2, or 6 over 2, times 3, if you're familiar, I know I've lost some of you now because not everyone likes working with fractions, but just real quickly, remember that it's like a 3 over 1. So you could write that 6 times 3 over 2. And then when we reduce, when we do the reducing, we're going to do 2 goes into 2 once, 2 goes into 6 3 times. So we're left with a 3 times 3, which lo and behold, look at that. It's still always firmly 9. So let me assure you, 6 divided by 2 times the quantity of 1 plus 2 is always 9, even back in 1892 and before. Printed in an arithmetic book, this problem would always still come back to 9. Well, I hope this has helped a little bit and maybe cleared up what misconception you had, and what a fun problem.